All right. I have 12:03 East Coast time, so we're going to go ahead and kick off here. Thanks everybody for tuning in. I'm Mike Kerrison, the application engineering manager for our fire protection business unit here at Alkegen. Who is Alkegen? Alkegen, formerly known as Unifrax. A lot of you probably know that name. Um, Long story short, a couple of years ago, Unifrax acquired a company by the name of Lidol that was about the same size as us, and it seemed fitting to kind of join together as one company under a new name. So that's who Alkegen is. Um, in terms of Unifrax, though, that's never going to go away probably. So all the certifications we're going to talk about today, specifications, engineering specifications, building specs, you're always going to see the name Unifrax on there, and that's intentional. So all of our certifications will remain under Unifrax. So if you're like thinking like, hey, who the heck's Alkegen? Are they new to this game? We're very not new to that game, and that's not going to change. So rest assured, Unifrax is there and will continue to be there. In terms of the presentation today, it's going to be technical in nature. So what that means is it's not a sales presentation. So yes, we're a manufacturer and we make stuff to sell. So yeah, you're going to see our solution to the issue at hand. You're going to see pictures of our stuff because that's what we've access to. We're not out there on job sites taking pictures of other people's stuff. So you're going to see a little bit of that, but I think, most folks, our feedback we get are pleasantly surprised that it's technical in nature and it's more about the technology and the code and the testing than it is, our products that we're selling. We're going to keep this kind of 25 minutes at the most. That's going to leave time at the end for questions. I have nowhere to be until 2 Eastern. So if the queue is filled with questions, I will stay and answer each one of those. We're going to have this recording available. So if you do have to drop off, we understand people are busy. You will have access to get back in there and watch the recording. And in terms of questions, you'll notice the chat function is off to avoid the banter. But no, put your questions in the Q&A. Everybody here has access to it, and you can put it in there anonymously, I'm pretty sure. So, but I would encourage you, if you have a question, ask it, please, because there's a lot of folks online, and I bet you somebody else has the same question, and they just may not want to put it in there. So please do that. Frank McLeod, he's our East Coast sales engineer for fire protection. He is going to moderate those questions at the end, so that way I'm not following through trying to read questions out of the queue. We'll get them all answered. We're going to flash some contact information. If you feel more comfortable, if there's an email on there, shoot your question into the email. We'll get you answered right away. So that's all I have, I think, for housekeeping stuff before we get going. So what are we going to talk about today? We're going to talk about dryer protection system, so acronym DPS. So what that is your clothes dryer in your home. So specifically in multifamily construction, so 3-story or less wood frame construction, there's dryers in there in the units, right? And so there's a dryer exhaust that goes out of the unit. So basically what we're kind of talking about, and there's our plug, okay, our product FyreWrap DPS. You have a dryer in the unit, the exhaust has to go somewhere, right? So what happens 99% of the time is the exhaust is going up through the wall and into the ceiling assembly, where it's then taken out of the building. So hopefully you could hear me over that music, or maybe there was no music. But anyhow, there's our 10-second commercial for our product. But that in short is what we're going to talk about here today. So just to get serious here for a couple of slides, and we here at Alkegen, we take this subject matter and all the passive fire protection things we do serious, because the root of it all is life safety, right? So that's the first and foremost. And then in addition to that is protection of property. So regarding this specific application, NFPA, so that's National Fire Protection Association, they publish data in 4-year sets. This set being the most recent available data, 2014 to 2018, roughly 14,000 structure fires having to do with laundry equipment. So that's washers or dryers. They don't break it out between washer or dryer, but it's, the real fire threat is a dryer versus a washer. So it's safe to say probably 2/3, maybe 75% of those are dryer fires. Anyhow, anyway you slice it, it's a really big number, even if it's only half. And the unfortunate reality is what you see in the bullets there below, right? So people, loss of life, injury, and then millions of dollars in property damage. And we could, I just have a couple of these in here, but it just brings it a little closer to home, right? So we could go on all day. We could do the whole presentation full of examples like this, but it's not necessary. So this one here specifically was outside of Indianapolis, Avon Creek apartment fire. If you Google it, you can read all about it. Um, Basically, a fire broke out. There was lint buildup in the dryer duct, and the fire broke out and spread amongst units. All 20 of those residents were not living in the same unit. So take a close look at the picture below, right? I see two front doors, I see two balconies, I see flames on both sides of that. So it spanned multiple units. You can see in the lower floor, upper floor. And we're going to talk a little bit about building construction, but the building code is in place to prevent things like this from happening. And if done properly, it will prevent that. So there's one example. And again, I'm not going to go through a whole bunch of these. I just have two here, but another very similar case, north of Atlanta, another 22 residents displaced. So it's bad news when these things happen, right? So luckily in these two instances, there was no loss of life, but people lost their homes and their belongings. So obviously that's serious. Okay, so I told you I was gonna talk about our product a little bit, and this is kind of where it stops, but I'm gonna share that with you. So Alkegen, like I said, formerly Unifrax, we are a manufacturer of high temperature insulation products. So when we say high temperature, we mean upwards of 2,000 degrees Fahrenheit. So we have a facility in New Carlisle, Indiana, so that's just outside of South Bend, where Notre Dame is, where we make a lot of these high temperature insulation materials. So in this instance, we're using them, the root was industrial products years and years ago, and they've evolved over time. And we use them, the fire protection team, for passive fire protection applications. So we're using insulation to slow down the spread of fire, basically, by preventing temperature rise. So what you see in the bottom right is a blanket, what we call a blanket product. What you see in the top right is a finished product. So we make a 1/2 inch thick blanket, and then we encapsulate it in a shiny foil scrim polyaluminized foil encapsulation. And that kind of does two things. One, it adds tensile strength for field insulation. And then the other is it's a canvas for product labeling. So you can see in the picture there, FyreWrap DPS is on the product. But in addition to that, we need to be able to identify the name of the product, but also the listing and labeling information. So UL and Intertech numbers and so on. So what that product is doing in a testing world and then a real world in the field is it's being installed on a dryer exhaust duct to provide a rated enclosure. So in this multifamily construction, 3 stories or less, they're built out of wood, and that's all 1 hour construction. So what that means is the walls and floors between units are going to basically contain the fire for 1 hour. So all of those things are tested and proven that that's going to work. But when you start to poke holes in it, that's when you start to introduce a risk of fire spreading from what we would call one compartment to another, or one floor, floor 1 to floor 2. And we're going to get into the code a little bit about measures that are in place to prevent that. But what's happening in this scenario is, so let's say you go in one of these units and you look up at the ceiling, you're going to see drywall. You look down at your feet, you're going to see whatever carpet or tile or vinyl flooring or whatever it is. Underneath that, there's a subfloor. Between the drywall and the subfloor, you have some space, 12 to 18, 24 inches. That's a great space to locate all of the mechanical things, right? Nobody wants to see the drain for the people upstairs for their bathtub coming through your unit. So they cram all that stuff into the mechanical space, which is great. But a dryer duct is a little different animal when it comes to putting things in a rated space, like a 1 hour floor or ceiling assembly. So the code has some specific language that gives guidance on what you do when that occurs. So this is an eye chart. You don't have to lean in unless you really want to. No one can see you, but this is a document that we use to kind of tell the story about the code path. So we're going to start in the building code. And so the building code is, I don't know, 1,000 pages, and it's kind of all things construction. Chapter 7 is where we kind of live, and that's the fire protection for the building. So I mentioned this compartmentation principle of how buildings are constructed. There's a whole chapter in the code that gives guidance on how to build a building and maintain that compartmentation principle. Meaning, if the fire starts on floor 1, it doesn't go to floor 2. If the fire starts in compartment A, it doesn't go to an adjacent compartment B. It's all about keeping the fire in the area of origin, so it can be extinguished with active protection, be it a sprinkler, extinguisher, first responder, and that allows folks to get out of the building occupants to escape safely. So, in terms of the building code, where do we go? There's a specific section for when ducts, they call them ducts and air transfer openings. When you start to breach these ceilings in these spaces, right? That's called a membrane penetration. So we'll just look at the building code definition of a membrane penetration. According to the IBC, a membrane penetration is a breach in one side of a floor ceiling, roof ceiling, or wall assembly to accommodate an item installed into or passing through the breach. So you can see the picture on the right there. That's exactly what we're talking about. You're taking these dryer ducts, you're running them up into the wall, breaching this membrane, so this rated assembly, and then you're traveling some horizontal distance inside that assembly until you're exhausting out of the building. So that's very specific to what we're doing here, but not specific to a dryer duct. It's any kind of duct system that's entering that space from the bottom side. And it's just a couple more shots of those ducts going in there, right? So they're running up in the wall, then they're going horizontal, traveling some distance to get to the outside where they can exhaust that air. And those are 1 hour rated floor ceiling assemblies. It's just another shot, right? You can see all kinds of other things in there, but what we care about are the dryer ducts that are originating in the units below, passing through that ceiling membrane into that 1 hour space. Okay, so the specific language in the building code, and the section that this lives in is 717 6.2. That's titled membrane penetration, so exactly what we're talking about. It basically says ducts and air transfer openings that penetrate the ceiling membrane of a fire resistance rated floor ceiling or roof assembly shall be protected with one of the following. Option one is a shaft enclosure. So I think a lot of us are probably familiar with a drywall shaft enclosure. So 4 walls or a box around the offending item containing the fire. Options 2 and 3 have to do with ceiling radiation dampers. As you might imagine, a damper in a dryer duct carrying lint is a bad idea. So while the building code doesn't say anything about dryer ducts, we're going to look at some language in the mechanical code that does. But if you just use common sense, right? If there's a damper in a dryer duct with some fins or anything in there, it's going to catch lint. So if you live in a house and you go outside where your dryer duct exhausts, you're often going to see some lint on the ground outside. You put a damper in there, that's going to catch in the damper. And so obviously that's an exponential increase of risk of fire inside that duct system. So that's what the building code does. Like I said, building code gives you kind of general guidance on all things, right? Fire protection in chapter 7, but it doesn't drill down into specific applications. It's going to kick you over to the mechanical code. For example, if you look in the building code for a grease duct, it's going to say see International Mechanical Code section 506. It kicks you over that way. And the mechanical code is going to give you very specifics on different mechanical systems. And today we're going to just keep talking about the dryer ducts. So there's a specific section in the mechanical code that deals with these membrane penetrations of closed dryer ducts. That's 504.2. Section 504 in the IMC is all things closed dryer exhaust. So specifically 504.2 deals with exactly what you do when these ducts penetrate these ceiling membranes into that 1 hour space. And it's really just 3 simple rules that you have to follow when you're doing that. One, and you can see it on the picture on the right, seal the annular space with approved fire caulk or non-combustible wall receptacle, right? The red stuff. It's not always red. In this instance, it is though, but that's probably the most identifiable. The second, don't penetrate or locate the duct within any fire blocking, draft stops, or any fire resistance rated assembly unless you do these 2 things. You build the duct in accordance with the table in 603.4. It just tells you steel gauge and construction, and you maintain the fire resistance rating in accordance with the IBC. So IBC tells you how to maintain a fire resistance rating. We just saw it on a couple of slides ago. Build a shaft or do dampers. Well, the mechanical code drilling down 1 step for a dryer duct says don't put a damper in. So now you're back to your one option, which is to enclose it in a shaft. So that's this option here, right? We kind of point in that direction. Anybody who's familiar with shaft construction, traditional shaft construction, knows that it takes up a little bit of space. So you can see kind of a cross-sectional view on the left there. If you were to take that assembly and try to cram it into the truss assembly that's inside your 1 hour floor ceiling system, you're going to have a problem getting that in there, right? You have your shaft liner, then an offset, and then a layer of 5/8. So your alternative to that are these wrap systems. They're field applied, duct is wrapped, it's 1/2 inch thick. All the systems out there are 1/2 inch thick. You're able to fit in that space a lot better than you are with the traditional shaft. So what happens a lot of times is just nothing, right? If people aren't aware of this code requirement or they're looking at building a shaft, it's impossible, right? So unfortunately, they move on. So in terms of testing, we're not going to get really specific, but if you do have specific questions about the testing, sure, I can get in the weeds there. Just ask the question and we'll go there. But just in light of being within our time here, we're going to be a little bit general about it. But it's not just us saying, Unifracs out there just saying, hey, yeah, trust us, it works. No, it has to be proven. So in the built environment, things have to be put to the test to demonstrate that we comply with the intent of the code. So that's exactly what's gone on with these products that are out there, or specifically I can talk to. So there's kind of a couple of parts here that go into this thing. One is the fire resistance of the duct system, right? So you have these ducts running in these ceilings that you'll never know they're there unless you know they're there ahead of time, or running in the wall or anywhere else. So the fire resistance testing is basically going to demonstrate that fire isn't going to use that duct as a conduit to spread from compartment to compartment, meaning it's not going to get out of the duct in the adjacent compartment. It's not going to get out of the duct in the compartment above. There's pass-fail criteria that demonstrate that your product as a system installed in the duct is going to do what it's intended to do if used as an alternative to a shaft construction. The other part, which is equally important, is the membrane penetration. So I mentioned these ducts are going into this floor ceiling space and they're traveling some distance before they exit the building. Well, in a real world scenario, right, there could be a fire inside that duct and now it's in that space. That's an opportunity for that to spread to the floor above. So it's actually tested to prove that is not going to happen, right? The fire is not going to use the duct to get into that space and then get back out of that space on the top side of that floor ceiling assembly. The other part is a through penetration, which is a lot less common in these applications because you tend to be just entering that space and going. But if there's a mechanical space or something like that where it ends up going up one and out the top, you may be in a situation where you need a total through penetration fire stop. We've tested that as well. Last but not least, it's subject to a hose stream when it comes off. So, the membrane penetration is tested just like a through penetration for those who are familiar with fire stopping. They pull that test assembly off and immediately following, they hit it with a fire hose in a zigzagging pattern, left, right, up and down for a set amount of time based on the test assembly. That is not entitled or intended to be like a fire hose, first responder fire hose, like what's going to happen. At that point, the fire needs to be extinguished. The purpose for that really is it creates a pressure differential and it's trying to push that fire stopping out of the annular space around the penetrant, in this case, a duct, which would constitute a failure. So if that stream of water goes through, you would fail because in reality, that fire stopping could be pushed out of there with a pressure differential, and then that fire would be allowed to spread to the compartment above. In terms of verification for testing, we would route you to this is all public documentation. So our systems are tested and listed with UL. There's systems out there that are tested and listed with Intertek, which is perfectly fine. But what these systems do, UL calls it a listing card, Intertek calls it a design listing. It's a summary of a test report. So that's not just us saying like, hey, trust us, we went and did this. Or hey, here's an 87-page test report filled with every data point, temperature on the test assembly as it goes on. They consolidate those test reports down into a listing, which gives the installation specifics for the system. It gives the hourly ratings. It gives the standard tested to. So what that's going to do is give a specifier or an inspector or a plans reviewer the tools that they need to feel comfortable approving these systems or specifying these systems for use. And then we take that documentation, which is public, and we build all of our product information sheets right out of there. So our product information sheets are going to mirror exactly what's in these listings from UL. because that's what was tested. So that's what we want to be installed out in the field, is exactly what was tested. So I know we have some folks from the inspections and the HA community online. So I just wanted to, and there's folks from distributions who might be asked to go out on a project and review and install to verify compliance with the tested listed system. So I just wanted to touch on that here, a couple of slides, just to hit the highlights of the install, which is pretty straightforward. Any joints where the product comes together, we have approval to do a compression butt joint or a 1-inch overlap. A compression butt joint, you're just building extra material into that joint, and that's going to prevent it from opening up. All the seams are going to be taped, exposed fiber. When you're all done with this, you shouldn't see any white fiber up there. It should all be taped closed, all the seams. And then it's just held on with 18 gauge steel tie wire or 1/2-inch banding. The banding is typically used on larger duct systems, but people do use it on the dryer ducts, and it is approved. I'm just kind of continuing on here with installation, just showing some, they're just cutting it there with an insulation knife, nothing fancy. Wrapping it in most cases lengthwise. So these are pretty standardized. Often they're 4-inch diameter. There are 7-inch as well. So we size the product specifically for those runs to be able to turn it lengthwise and run it out. So it's a 25-foot long roll. You can run a 25-foot long piece if you choose. More folks now are doing a little bit of a prefab. So you can see that picture on the right. They were wrapping all these, leaving a little bit on the ends and just stacking them all up and then installing the ducts. Not a problem, as long as you abide by the installation, which is 1-inch compression butt joint or 1-inch overlap, where the seams come together. It's no problem to do it on the floor or a table and then install it up there in place to make it just a little bit easier. Okay, just a quick recap. That was a lot in a short amount of time, but just kind of breaking it down here. So high level, the IBC requires a shaft enclosure or a damper. Drilling down to the IMC, you cannot put a damper. So those two options are out, right? Maintain the fire resistance rating in accordance for the IBC. So you're back to a shaft. So you have these options. You build a shaft or a field applied wrap-like product, at least in what we're talking about today. And then in terms of system documentation, it's all public. If you don't have it and you're responsible for verifying that's installed in accordance with the listing, or if you're a specifier, ask for the documentation. I'm going to put up our contact info on the next slide here, and then just verify that it's installed in accordance with the listing. So I mentioned there's a couple manufacturers doing this, and that's great, but we each have a little bit of difference in between the systems. So you just know your manufacturer that you're using or specifying, and just verify with the appropriate documentation from said manufacturer. And this is less of a recap, more of just a statement. Municipalities and the architecture and engineering communities, they're becoming increasingly aware. So we do a lot of education as Alkegen, and we participate in some industry associations that also do education as well. So the more we educate, the more people come aware of these scenarios. So we want people to be aware of the scenarios before there's more stories like the slides that I had in the beginning of the presentation, right? If we do this up front, we specify it, we require it in the individual municipalities, it prevents those things from happening. So that being said, that's the content. We're going to get to questions next, but I guess I'll just say one other thing. As you're looking at our contact information, feel free anytime to reach out if you have questions about this or any other duct related applications, passive fire protection. We can help you out. And if you have specific conditions on a job site that don't seem to match what's on the data sheet, give us a call or shoot us an email. We're here to support you. So that's all I had. I tried to keep it to the 25. It went a little long. I apologize. Hopefully you can stick around for questions, and I'll turn it over to Frank to ask those questions of me.
All right, thanks, Mike. Got a few questions here, and actually one just came in that's similar to another, so we'll ask them at the same time. I'll be kind of summarizing some of these questions as they're coming in. Do you have multiple products for DPS application, or is it always the same product used? And related to that, can you use plenum wrap for this application?
No, you can't. So those who aren't familiar with the plenum wrap product, it's another product that the same manufacturers, we all offer one. That the intent of that product, even though it's a 1/2 inch and it looks a lot like the DPS, the intent and the testing that are associated with that product are for enclosing combustible items like PVC pipe and data cable and things like that that are located in a plenum space, because the code has restrictions on the type of things you can have in there. So it brings those into compliance. The reason why you cannot use it, even though it looks and feels the same as the blanket, the core blanket that's in the DPS, is an enhanced version of the plenum. So you don't want to put that on a dryer duct. It may not perform as well.
And as for other products for this application, is it always DPS, or could we use other products for that?
So we have a product called FyreWrap Elite 1.5, and that product's primarily used for commercial duct applications like commercial kitchen grease duct or air distribution systems. However, when we did the testing for DPS, we did include that product on our listings. So let's say you're in a jam and you have a job going on today, and your local distributor has the Elite, but they don't have the DPS, you can put that on there and it still complies with the listing.
All right, thanks. Thank you. It looks like somebody had a hand raised. If you could hop in the Q&A section and just type your question in there, we'll get to that in just a second if you still have that question. Is fire stop where it enters the ceiling enough?
Like where it goes up through the wall, like through the wall?
I believe where we're talking about, where it's entering that lower membrane.
No. So we get confusion once in a while there's some exceptions to the ceiling radiation dampers in the building code. So we get some questions about that once in a while, where folks think that exception would apply to a dryer duct. But remember, I said back in the slide, I said the building code is kind of I don't know what I said, all encompassing or a higher level that outlines protection requirements, and the mechanical code drills down a little deeper. So the mechanical code, so building code is kind of all things, right? Air ducts, like all sorts of things. The mechanical code is specific to dryer ducts for this section. So there's a lot of sections that are mirrored in the mechanical code and building code when it gets to the actual protection. So this is one of them. It's an almost mirror, but in the mechanical code, those exceptions are specific to an air duct, not to a dryer duct. So the long answer to the short question, I guess I just gave you that the answer is no, that's not enough, but it may have been related to those exceptions that are in the building code, but they don't apply. We need to refer to the mechanical code.
All right, and it looks like we have one more, unless any more come in, and there's actually a couple on this. Generally, are there any other ways to handle this situation outside of using a wrap product like we're talking about today?
Yeah, so the wrap product is primarily, your time to use that is going to be when the duct is in that floor ceiling space with all that other stuff. So it's like impossible to build a shaft in that space. So that's where your wrap product is going to come into play. But the way the code is structured, remember it said if you penetrate the ceiling membrane. So if you don't penetrate the ceiling membrane, let's say you run the dryer duct below the ceiling and then just do like an aesthetic soffit, or just like a corner drywall in the corner, that's perfectly acceptable because you haven't entered that rated ceiling space. So that would kind of be the other way to do that. And then I know I think like the state of Carolina gives you an option to kind of alter that ceiling assembly. But you said you're kind of doing the same thing. You're not entering that ceiling space. So that would be your other option. If it doesn't go in that space, you can just do that aesthetically.
Thank you. We just had another question. I think it sounds more like FyreWrap, just in general. Is FyreWrap FM approved?
No, FM doesn't get into the commercial applications, to my knowledge. We asked them about it some years ago, and they weren't really doing that. They would, I guess, if they witnessed the testing, but none of us did that. We do have a product that's FM approved. It's for industrial use though, and like cable trays and conduits and things like that. It's called FyreWrap cable insulation, but the FyreWrap Elite and the DPS for commercial applications are not FM approved.
Yeah, if I remember correctly, Mike, that they don't really have a formal approval process for those commercial applications, right? It's mostly their internal things.
Yeah, that may come someday if demand drives it, but today it's kind of outside of their expertise, is my understanding.
Okay, another material-based question. When manipulating insulation wrap, is it dusty, and do you need to provide protective equipment to do so?
Um, yeah, so we always recommend just your standard kind of PPE. So I guess one thing I did not mention with this product, so to answer the question first, and then I kind of have a follow-up statement, I guess, to answer it. Everybody's different in terms of like how sensitive they are to the product, and how, if it irritates or whatever. So like I've installed a ton of this at the test lab. It doesn't really bother me, but it does bother people more than others. So our recommendation always is just, like a standard dust mask, gloves, long sleeves. That's going to keep any loose fiber off of your person. It's not like you slap it and there's this big cloud of dust in the air, but as you work with it, you can get that fiber kind of moving a little bit. But good practice, I guess, that would help alleviate a lot of that would be taping your pieces before you pick them up. So you saw the one picture there, they're rolling it out on the floor, they're cutting it to length. If you tape up that envelope then, as opposed to install it first and then tape it up, you would mitigate a lot of that kind of airborne stuff. Second to that, aside from like the skin irritation that some people might get, because it's a fibrous product, the base product. So I showed that picture of the white blanket material. That's what we call, or the industry calls, it's not we us, but an LBP, so low biopersistence fiber. So what that means, it doesn't come with a warning on the box that it's hazardous to your health. Your body can eliminate those fibers, so they're not going to stay in your lungs or anything like that.
Great. We can hang on another minute or two. If anybody else has any additional questions, drop them in the chat. If not, you can see the contact info there. Or if you have any of your sales engineers' contact info, you can reach out to us directly. Give a minute or so here if anybody wants to put anything in. If not, we'll wrap it up. Oh, there is one. Look at that.
Right.
Okay, this is according to the 2024 IMC commentary for Section 504.2, domestic dryers are permitted to comply with the exception for ducts in 607.6.1. How does this factor into the discussion today? So I think that goes into those exceptions we are talking about for specific to the mechanical code.
Yeah, you read that fast, but yeah.
I can slow that down a bit. Look at the Section 504 domestic dryers, 504.2 domestic dryers are permitted to comply with the exception for ducts in Section 607.6.1.
Oh, yeah, that takes you to the what I call like the duplicate section, but the section in the IMC specifically states air ducts where the one in the IBC does not. So the one in the IMC pertains to an air duct. So hopefully that answers the question.
So it's not specific to the dryer duct section.
Yes.
Anything else? I think that looks like we've had about 30 seconds there for anything to kick in. I'll just say I appreciate everybody who's still on, everybody who's stuck around. We hope to do more things like this. As I say, there's another question. Like we said, we'll stick around as this is a commentary says the air duct section applies from the same individual about the other section. Maybe this is we talk about get in contact and have a further discussion on this directly with them. We can pull those mechanical section ducts up specifically.
Sure.
That's information we can share after the fact. If I don't want to call your name out, but if you just reach out to Mike directly on the email on the screen, we can have that discussion a little bit more direct. All right, I think that's it. Thank you for everybody for joining. We appreciate it. We hope to do more of these type of things on this topic and others in the future. And as we've said several times, please reach out for any additional information, questions, comments, concerns, that sort of thing. Mike, unless you got anything else, I think we'll shut her down.
Nope. Thanks, everyone.
Thanks, everybody.